algorithm, radix to FFT algorithm. Okay, FFT is fast Fourier transform. FFT is more efficient than your discrete Fourier transform algorithm. Why? Because in the derivation of DFT itself you can able to see that you will have more number of multiplications and more number of additions. Okay, so DFT will be less efficient than your FFT algorithm. Okay, so in FFT algorithm it is divided into DIT and DIF algorithm. DIT is decimation in time and DIF is decimation in frequency algorithm. Here you are going to learn decimation in time fast Fourier transform. First you must understand what is radix 2. Consider 8-point sequence and 8 can be written as 2 power 3. Here 2 states the radix and 3 states your number of stages of your flow graph. Okay, so consider n is equal to 9. You can write it as 3 power 2. Here 3 is your radix and 2 is the number of stages of your flow graph. In general, the radix 2 algorithm is mostly used. Okay, why? Because it is more efficient than your radix 3 algorithm. Okay, so here you have n point DFT. N point can be separated as n by 2 and n by 2. N by 2 is for odd and even. Okay, f1 of n is for even function and f2 of n is for odd function. Here the function can be written as x of 2m for even and x of 2m plus 1 for odd. Why? Because m varies from 0 to n by 2 minus 1. Here when you substitute m as 0, you will get x of 0. When you substitute m as 1, you will get x of 2. When you substitute m as 2, you will get x of 4. This is for even functions. Okay? And here when you substitute m as 0, you will get x of 1. When you substitute m is equal to 1, you will get x of 3. When you substitute m is equal to 2, you will get x of 5. This is for odd function. Okay? So since n minus 1 can be divided into even and odd, your sample limits varies from n by 2 minus 1 and n by 2 minus 1. Okay? You know the DFT formula, right? X of k is equal to summation n equal to 0 to n minus 1 x of n e power minus j 2 pi n k divided by n. Okay? So here in order to simplify the derivation part, you are introducing your twiddle factor. Twiddle factor is nothing but your set of values. And please don't get afraid by looking at these derivation. I will make you to understand the simplest method. Okay. First you should write the DFT formula. In DFT formula instead of E term you are introducing twiddle factor. Okay. So twiddle factor Wn nk is equal to e power j minus j 2 pi nk divided by n. And x of k is equal to summation. I am dividing this term into odd and even. Okay, I am dividing this term. So summation n equal to even x of n wn nk plus summation n equal to odd x of n wn nk. And this function is f1 of n and this function is f2 of n. This is even, this is odd. Okay, so same way your limit also can be divided into 2. So you can write this equation as x of k is equal to summation m equal to 0 to n by 2 minus 1. This is for even. X of 2m w n. Instead of n you have to substitute 2m k. Okay, plus summation m equal to 0 to n by 2 minus 1. This is for odd. X of 2m plus 1 wn. Instead of n you are substituting 2m plus 1 into k. This is for odd term and this is for even term. Okay, so you know the values of m which varies from 0 to n minus 1. Okay, for even n by 2 minus 1 and for odd n by 2 minus 1. Okay, so when you substitute the values in this equation, you will get x of k is equal to x of 0, x of 2, x of 4 and x of 6. Okay, so here you are considering n is equal to 8. So n minus 1 is 8 minus 1 by 7 and n by 2 minus 1 is n by 2 is 8 by 2 minus 1 which is 4 minus 1 and 3. For this you will have 0, 1, 2, 3. And for this you will have 0, 1, 2, 3. So when you substitute 0 here, you will get x of 0. When you substitute 1, you will get x of 2. When you substitute 2, you will get x of 4. When you substitute 3, you will get x of 6. And same way here, when you substitute 0, you will get x of 1. When you substitute 1, you will get x of 3. And when you substitute 2, you will get x of 5. When you substitute 3, you will get x of 7. So totally from x of 0 to x of 7 you have got. Okay, that's it. And next, consider this one. X of k is equal to summation m equal to 0 to n by 2 minus 1 x of 2m w n by 2 mk. So this is nothing but your twiddle factor. I have given the explanation here. Wn 2mk can be written as e power minus j 2 pi by n 2mk, okay, which can be written as e power minus j 2 pi divided by n by 2 into mk. And this e power minus j 2 pi by n by 2 can be written as wn by 2. Why? Because w is e power minus j 2 pi, okay. So wn by 2 mk. This is what I have substituted here, wn by 2 mk. Okay, and here when you look for odd, you can multiply 2m into k, 2mk, 1 to k. Okay, so in the next equation, x of k is equal to summation m equal to 0 to n by 2 minus 1, the same thing, plus this term I have taken outside, wnk. Okay, summation m equal to 0 to n by 2 minus 1, x of 2m plus 1, w n by 2 mk. Okay, and here, so this term can be written as function of k, and this term can also be written as function of k. So this is f1 of k and this is f2 of k. Okay, and already we know the value of x of 2m is f1 of m. That is what I have written is here. Okay, so when you substitute this f1 of m and when you substitute for this one, you will get f2 of m. So this is function of k, f1, capital F of f1 of k, and this is also function of k, here f2 of k. Okay, so whereas your f1 of k and f2 of k is your n by 2 point DFT of the sequence f1 of m and f2 of m. Okay, and this is for one half of the sequence, which is n by 2. You have to find out another half. For finding out another half of your spectrum, you are using periodicity property. The periodicity property states that f1 of k plus n by 2 is equal to f1 of k, and here f2 of k plus n by 2 is equal to f2 of k. Okay, your sample varies but the function remains same. Here you can substitute x of k plus n by 2 is equal to f1 of k plus n by 2 plus wn. Instead of k, you are substituting k plus n by 2, f2 of k plus n by 2. Here consider this one, wn k plus n by 2 equal to wnk into wn n by 2. So this can be written as e power minus j 2 pi k by n and into e power minus j 2 pi n by n into n by 2. So here when you cancel n and 2 you will be getting e power minus j pi. E power minus j pi is nothing but your cos pi minus j sin pi. Your cos pi value is minus 1 and sin pi value is 0. So you will be getting minus 1. So instead of this one you are substituting minus 1. So you will get minus into e power minus j 2 pi k by n. So your twiddle factor states that minus wn k. Okay. So when you substitute this one in this function, you will get x of k plus n by 2 is equal to f1 of k minus wn k f2 of k. You know that f1 of k plus n by 2 is equal to f1 of k and f2 of k plus n by 2 is f2 of k. Okay, and this is for the another half of the sequence. So that's it. So this is for the first half of your sequence and this equation for the second half of your sequence. Now you just consider n is equal to 8 and your k varies from 0 to n by 2 minus 1. Here n is 8. So 8 by 2 gives you 4. 4 minus 1 is 3. So k value is 0, 1, 2, 3. Okay. Now you just substitute k values in this equation and also in that equation to see what happens in the flow graph. Okay. So when you substitute k equal to 0, you will get x of 0. f1 of 0 plus w8 power 0 is 0, f2 of 0. When you substitute k is equal to 1, you will get x of 1 which is equal to f1 of 1 plus w8 power 1, f2 of 1. When you substitute k is equal to 2, you will get x of 2 which is equal to f1 of 2 plus w8 power 2 into f2 of 2. When you substitute k is equal to 3, you will get x of 3 which is equal to f1 of 3 plus w8 power 3 f2 of 3. And same way here, when you substitute k equal to 0, you will get x of 0 plus 8 by 2 because x of k plus n by 2 you are having here. So when you substitute 8 by 2, you will get 4. So that is x of 4 which is equal to f1 of 0 minus w8 0, f2 of 0. So same way, when you substitute k is equal to 1, you will get x of 1 plus 4, you will get x of 5, f1 of 1 minus w8 power 1, f2 of 1. When you substitute k is equal to 2, you will get x of 6 which is equal to f1 of 2 minus w8 power 2, f2 of 2. When you substitute k equal to 3, you will get x of 7 which is equal to f1 of 3 minus w8 power 3, f2 of 3. Now you have got all the sequence from x of 0 to x of 7. Okay. Now you are going to find out the value for your middle factor. Then only you can use it in your flow graph. Okay. So now you know Wnk is equal to e power minus 2 pi by n into k. So here you are going to substitute the k values and see what is your exact value for middle factor. Okay. So when you substitute k equal to 0, you will get w8 power 0. So when you substitute 0 here, you will get e power 0 which is 1. Okay. When you substitute k is equal to 1, you will get w8 power 1. So e power minus j 2 pi by 8 into 1. So when you cancel it, you will get pi by 4. So you can able to write this term as cos pi by 4 minus j sin pi by 4. So cos pi by 4 value is 0.707 and sin pi by 4 value is 0.707. Next, when you substitute k is equal to 2, you will get w8 power 2. So e power minus j 2 pi by 8 into 2. So when you cancel it, you will get e power minus j pi by 2. So cos pi by 2 minus j sin pi by 2. Cos pi by 2 is 0. So you will get minus j sin pi by 2. This is 1. So you will get minus j. Next, when you substitute k is equal to 3, you will get w8 power 3 which is equal to e power minus j 2 pi by 8 into 3. So when you cancel it, you will get e power minus j 3 pi by 4. So this can be written as cos 3 pi by 4 minus j sin 3 pi by 4. So the value of cos 3 pi by 4 is minus 0.707 and sin 3 pi by 4 is 0.707. So you have this equation. So you have to use these tilde factor value in your flow graph. Okay. And the next concept is bit reversal order. So in DIT FFT, your input is in bit reversal order. Okay, bit reversal order. Your output is in normal order. Okay, when you consider DIF, your input is in normal order and your output is in bit reversal order. Okay, so I will explain both the concept in the flow graph. Now you just see what is bit reversal order. So binary values can be expressed as 8, 4, 2, 1 as per the value, the places of the points. 2 power 3 can be written as 8, 2 power 2 can be written as 4, 2 power 1 is 2 and 2 power 0 is 1. Okay, here you have 3 values. So you just consider 4 to 7. You have 0 to 7. So we are considering only 4 to 7. So here for x of 0 you will have 0 0 0. For x of 1 this place will be 1. For x of 2 this place will be 1. For x of 3 both the places will be 1. So you can write 0 1 1. For x of 4 this place will be 1. So same way you have to write from 0 to 7. Okay. So when you reverse it 0 0 0, when you reverse this one you will get 1 0 0. So this is nothing but your value is 4. When you reverse this one you will get the same value. When you reverse this one you will get 4 2, you will get 6. When you reverse this one you will get 1. When you reverse this one you will get the same value. When you reverse this one you will get 3 4 2 1. So 2 1 1 is 1. So your answer is 3. So when you reverse this one you will get the same answer. Okay, I hope you have understand the dual factor values and the bit reversal concept and also the n by 2 sequence of your DIT FFT algorithm. Okay, this is the simplest method of deriving your DIT FFT algorithm. So I hope you have gotten clear idea about this algorithm. In the next video, I will be showing the flow graph of this algorithm. Okay, thank you all.